Okay, all right, so now we're working through different properties that occur over different operations. So the operations are a way that we can put numbers together. So some familiar operations are addition, subtraction, multiplication, and division. Those are operations we have to work with, numbers. And now we're going to see if they exhibit certain properties. So these properties, we're going to go through one video at a time. The first video is dedicated to the identitive property. And that's just saying that whatever my operation is, should it be addition, subtraction, multiplication, division, whatever it is there some sort of I that exists such that if I take any number, a real number, which we have some familiar with what that means, a real number, and we use that operation with this element, not 1, but it will be A. And traditionally this I is written as 1. So do we have some element such that if I do something with A to it, I get A. So can A have its identity preserved somehow? So let's work through each operation that we're familiar with and identify the identity. So let's just let A be any real number like 5, -2, 0 even. Is there something I can do to it with addition? Does this blank exist so that it's the same for any number? Yes, I can, right? I can have an identity. Now, and the thing about the identity is it should work either way. So, does it work this way as well? Yes. So if I do it to either side, I get the same thing back. So there is an identity for addition. So for addition, the identity is 0. All right, I think you guys might be able to guess what I'm going to do next. So next we're going to explore subtraction. So with subtraction, is there something I can subtract and get A, and also subtract it this way with A and get A? So you might think 0. Okay, sure, A minus 0 is still A. Cool deal. But if I try that here, 0 take off A is actually -A. So it's not working. There actually isn't an identity for subtraction because it won't work either way. All right, next operation. So with subtraction, there is not an identity. Sad face. Can you see that that's a sad face? Okay, so next we'll try out multiplication. So if I have A times something, where A could be any number, do I get A? And can I do it on the other side of A and also get A? Does anything like this work for multiplication? I would argue yes, right? So if I multiply A by the number 1, and I also multiply the number 1 by A, I'm going to get A. So A has this way of preserving its identity. When it comes to multiplication. So if I take A and I multiply it, because that's the operation at hand, by 1, I preserve my identity of being A, right? So -2 multiplied by 1, it's still -2. It's preserving its identity. And that's what it means to have the identitive property. So multiplication does have the identitive property with identity 1. So we can jot that down. So for multiplication, just keeping tally, I do have the identity and it's the number 1. All right, we've got one more familiar operation to check out. Can I do A divided by something and still get A? And can I also do that same something divided by A and preserve my identity of being A? Can I stay as A? And the answer here is no, because we're dividing, right? So you might be tempted to think 1 would work, that the 1 for multiplication works, but in fact, this would be 1 over A. So it does not equal A. So I can write that down too. For division, we have no identity, so it doesn't exhibit the identitive property. So the real numbers are not, don't exhibit the identitive property over division. And so you notice that there's an identity for addition and there's an identity for multiplication. And there isn't one for these guys, the subtraction and the division. And you can think of that, part of the reason why is because this is like an inverse operation of addition, right? If I add 2, how can I unadd it? That's when we come up with this property of subtraction. And when I'm multiplying, how do I unmultiply? That's when I come up with the operation of division. So a lot of the reasons that this pattern is sort of happening is because these are inverse operations of these original operations. So you can think about that a little more, and I hope you just understand that the reason we call it the identitive property is because it means that there exists something that you can perform either side on and preserve your identity as what you are as a number. All right.